9.2 Graphs of some common functions. Here, common functions. For those you've learned before, maybe not all of them, just some of them. Let's see about those functions and have a look the features about the domain, range, maximum minimum value, axis of symmetry, and did they have a period or not. Okay, let's see. The first one, fx equals to k. What kind of function here? We have a name here, constant function. Constant function. What is constant function? That means, okay, here you have a straight line, okay, see this one. If y equals to k, then it's a constant function. That means what value of x, y always equals to k. Okay, so let's see. So the domain is all real number. How about the range? This time range only one value, k. So maximum or minimum value also is k. Then what is the axis of symmetry? That means if you draw that axis, then you can cut it as two sides and the graph have a symmetry. Okay, that means have a look here, have a symmetry properties. So let's see, I draw the vertical line here, then you see that this one symmetry, right, symmetric to each left hand side and right hand side. For example, I draw like this, also have a property of symmetry, right? Left hand side equals to right hand side, right? So again, maybe here you need to know the straight line is no ending, right? So whatever which vertical line, it still can be the axis. So here you see that any vertical line means like this. Okay, however, least positive period, no. Okay, so I cancel out here, I cross out here. Okay, let's see the second one, fx equals to mx plus c. This one as a linear function or linear equation, right? X, y, right? And y equals to mx plus c. Y equals to mx plus c, right? So this one we say that is the linear function. Okay, what is the domain? Any value of x can be domain, right? So all real number again. How about range? That means y. Yeah, again, it's a straight line. Okay, so all real numbers. Okay, all real numbers, except slope m equals to 0. Okay, suppose m not equals to 0, so I write down here. If m equals to 0, then becomes constant function. Then the range only k. Okay, how about the maximum minimum value? About the linear function, there's no maximum or minimum value because straight line also no endings, right? Straight line, okay, no endings, so you cannot see any maximum or minimum value. Okay, so no such things. How about the axis? This time difficult to say about the axis of symmetry, right? Okay, So also no period. Let's say the third one, quadratic function. Quadratic function. Do you remember quadratic function? Yeah, this one. Actually, we can separate as two different kinds. One is opens upward, right? One is opens downward. Remember? A greater than 0, or y equals to ax squared plus bx plus c. And this one, a smaller than 0, right? Good. So, domain of x all real numbers again, okay? And for a greater than 0, what is the range of graphs? Remember, we have the maximum and minimum point, hk. And this hk actually equals to negative b over 2a and negative delta over 4a. Remember? So here, for a greater than 0, then y greater or equals to negative 4 delta over 4a, right? Because this one as the minimum, so greater than this value. However, for a smaller than 0, then y was smaller than or equals to negative delta over a, 4a, right? Because maximum or minimum value, we say that is a negative delta over 4a. Negative delta, okay, you may say that is negative or 4ac minus b squared over 2 over 4a, right? This is the maximum or minimum value. Okay? How about the axis of symmetry? Yeah, just now we say that hk is the maximum point, minimum point. So according to value of x, then this one as axis of symmetry. So negative b over 2a. X equals to negative b over 2a, this vertical line. Okay? Lastly, no period. Okay? We cannot find any least positive period. Okay? Goes on. Sine function, cosine function, and tangent function. Free trickle function. Do you remember? This one, yeah, you say that like this, like a waves curve. Okay? Cosine function, similarly, like this. Yeah. How about tangent? Tangent function will become like this. Right. So 3 kinds of trickle function. Do you remember? For sine, cosine, domain of these two functions, again, all real numbers. All can find the value of y, whatever which value of x. Okay. So what is the range? Yeah, these two have a range. Y in between -1 to 1, correct. Also for cosine. Okay, therefore the maximum and the minimum value is 1 and -1. 1 and -1. And how about axis of symmetry? Okay, maybe a little bit difficult to explain it, but let's try. For example, here we have a sine curve like this. Okay, so if we draw a vertical line like this, then you can see that this one symmetry, okay, will have the property of symmetry as x equals to h. For example, this one 90 degrees, okay, or If we don't want this one, okay. How about this? Yeah, 270. Okay, also can have the properties of symmetry. Okay, so x equals to h for certain values. X can be the axis of symmetry. Okay, how about the period? Do you remember? Yeah, start from here to here, right? 360, right? So we say that the least positive period is 360. Okay, here we have x degrees, so we no need to write down degrees. Okay, how about cosine theta? Cosine theta will become like this, right? Okay, not so beautiful. Maybe draw once again. Yeah, like this. So again, if we pick up this one, okay, this one is 180. So this one can be the axis of symmetry, right? How about this? Sorry. Yeah, it also can be the axis of symmetry, because if this cosine curve keep on like this, then it becomes another axis of symmetry. This one 0 degrees this time. Okay, so you see that when x equals to h, for h equals to negative 360, 180, 0 degrees, or etc., it can be the axis of symmetry. Again, how about the period? Again, 360 degrees, right? So the answer 360 for cosine. Okay, how about tangent theta or tangent x? Yeah, all real number about the domain, all real number except why we have exceptions. Yeah, do you remember tangent theta, some values of x we cannot find any corresponding value of y, that means undefined, right? So negative 270, negative 90, 90, 270, etc. Okay, so this one, and this time tangent x, about the range of tangent x is all real number, right? Because we can goes up to infinity, and after 90 degrees from the negative infinity, and then again goes up like this. Okay, so you find that all real number as the range. Therefore, no maximum value, no axis of symmetry here. Okay, and how about the period? Yeah, do you remember? Yeah, 180 degrees. Yes, so here is 180. Okay, good. Last two function, do you remember? Fx equals to y, a to the power x. Yeah, we say that is the exponential function. Okay, and exponential function, do you remember we have several kinds of exponential function? Maybe you say that can cut it as two. One is like this. Okay, x, y. Yeah, this one, y equal to a to the power x for a greater than 1. Okay, and for the other one, will become like this. Yeah, like this. For A, in between, okay, maybe I write here. For the orange one, A in between 0 to 1. Do you remember? Do you remember? Yeah. So we have two different kinds. Okay. And do you remember if I draw two lines here this time? One is like this. One is like this. Maybe use this one and thinner. Okay. Number 1 and number 2. If now I have y equals to 2 to the power x, y equals to 3 to the power x. Which one is purple one? Which one is blue one? This one is number 2. This one is number 1. Do you remember? Yeah, correct. This one is number 1. Okay? And this one is number 2. Do you know why? Yeah, just easy to find it. Because when you use, okay, for example, x equals to 1. This one is 2. And this one is 3, yeah. Y equal to 3 to the power x goes up faster. Have the greater slope, increasing, right? So you can revise this chapter 7, okay, in book 4b. Now have a look about the log function. Log function, okay. Not finished yet. Have a look here. How about the domain and the range of this kind of function, exponential function? Yeah, all real number as the domain of exponential function. Okay. How about the range? Yeah, you remember, right? All positive real number are the exponential function, range of exponential functions. Okay? No maximum, minimum value, and no axis of symmetry, even no period. We cannot talk about the periods, okay? How about log function? The last one, log function. Let's see. Here, log function, same as exponential function, will have two different situations. Have a look. X, Y. Do you remember about this function? Yeah, one is like this. Right. How about the other one? One is like this. Okay, I use the other color. One like this. Right. The differences between these two is one is a greater than 1. A greater than 1. Okay? Which one is a greater than 1? Do you remember? If you forgot, you can find one example. For example, log 100 equals to 2, right? Log 10 equals to 1. Log 1000 equals to 3. That means when x increase 10 is 1, 100 is 2, 1000 is 3, so you can see that this one a greater than 1. okay, base 10, okay. So for the other one, a in between 0 to 1, right? Okay, so here about the log function, you see that domain only here, that means all positive values number for the domain, okay. The curve will not lies on the left hand side of y-axis, so domain only all positive real numbers, okay. How about range? The range is all real numbers, okay, all real numbers, okay. So the last question wants to remind you, for example here, again we have the curve, and this time 1, and use the other one, 2, like this. This one as 1, this one as 2. If now we have two log function, for example, y equals to log 2x, log x base 2, y equals to log x base 3, which is 1 and which is 2. Yeah. Give you some hints. When y equals to 1, okay, when y equals to 1, then you cut at 2 points, okay. One is this one is this one, right? Then can you tell me when y equals to 1, what is x here? Yeah, x equals to 2, correct. How about this one? Yeah, x equals to 3, correct. So you found that this one is graph 1, right? And this one is graph 2, okay? So you see, all different functions have different properties, and you need to remember about the domain, range, maximum, minimum, axis of symmetry, and understand about the period of different functions if they have, okay.